Okay, here we are. Good morning, everyone. Okay, sorry for the misunderstanding in the schedule. Yeah, there were some problems going on. So now we were rescheduled now. Yeah, I'm trying to figure out if there are all the speakers now. So it seems the case. Yeah. So let's start by sharing the screen with you, because introducing you to CVEB workshop. Okay, are you everybody seeing the slides? Please tell me something about it. Okay, thank you so much. Okay, now let me see if also the Discord channel is running. Okay. I don't know if there's something. Okay. Please, yeah, the other organizers, there's something strange on the Discord channel, please monitor it. I will try to do my best also with that tool, but let's start more to the for the program. So basically, we are starting the 7th edition of Sonic Interactions in Virtual Environment. And sorry again, apologize for the misunderstanding in the program. And let's present at least the list of the organizer. I'm Michele Geronazzo. I'm associate professor at the University of Padova, with other colleagues from the AAU, Stefania Serafin, Chumur Erkut, Nielsen, Ali, Arju. Sorry for the pronunciation. I always it was a mess sorry, Ali. And all of the other colleagues are from Aalborg University. I was also at Aalborg University when we organized the first editions of CIVE, and also there's also Federico Vanzini from University of Milano, which is, I would say, a friend of ours, and we started this this workshop at IEEE Virtual Reality in 2014. Everybody knows here, but if not, please have a look at our official CIVE webpage, and you will find the six past editions. And everything started in 2014 at the Minneapolis, the US, and the story of CIVE. I think it's quite interesting because it started as a workshop, but progressively becomes something more than a workshop. So we are still running this workshop, and this is the reason why we are here now together discussing about sound in interactions in virtual environments. In the past, in particular in 2018 and 2019, we wrote two review papers, one from the IEEE Computer Graphics Journal magazine of the IEEE, and another one, more recent one, in the Journal of New Music Research. So basically, from more technical perspective to more artistic or exploitable, say, the application domain of what we can be defining as immersive technologies with sound. And finally, we are publishing a book on Springer and for the human-computer interaction series, and it will be published hopefully in the end of the spring or summer, depending on the production team by Springer. But it's quite relevant for this workshop that we found a way to create something new, I would say. So the result of these 8 years of discussing, doing research together, and also sharing our perspectives, our knowledge with the research community and different research communities from different perspectives, gives birth to something that can be called a research field. So we tried with, especially with this book, to formalize an inclusive perspective of what we call sonic interactions in virtual environments. And this is a very, very simple structure, an inverse pyramid representation. And it's basically, it's the immersive audio technologies in this pyramid are the enabling potentials and technologies for building sonic interactions and sonic experiences, which could be potentially interactive and immersive. So from this perspective, for this simple structure, you can extract, it's evident that this field is highly multidisciplinary. So from an engineering and computer science perspective, and of course, a lot of digital signal processing applied to audio, to a human-computer interaction perspective. So involving psychology, ergonomics, cognition, and for sound, it's extremely important, the body and the movements. So all the fields regarding the movement analysis and motor sciences, and the integration of such fields in the broader perspective of a multimodal scenarios, multimodal applications. So basically involving the other modalities rather than audio. And the key message of CIVE is that it's intrinsically impossible to have audio only experiences. So when we think about, when we are designing sonic experiences, we are doing it with a multimodal perspective, with an audio first, or audio mainly, only an audio which is a major perspective of the audio auditory information, right? Okay, today we will go through a short program, which is nicely divided into the three subcategories of CIVE. The three subcategories are very nicely identified by our book, and they are the immersive and interactive audio technologies, and basically the technologies for sound specialization. Then there's the second group of let's say cluster of topics, which is mainly devoted to sonic interaction design. So we have the interactive the interaction design component here in a second presentation, and then there's a third cluster of interests of topics, which is the let's say embraces all the sonic experiences with this multimodal point of view, and of course a key component, a key contribution, it's better, to sonic experiences is made by the musical communication, musical interaction, musical instruments, and the, let's say, the symbolic part, the higher level part of the audio communication channel. Okay, so now we will go through this program, and we will give 10 minutes for the presentation. Of course, we have, let's say, that the schedule allows us also to be more flexible in this, allowing everybody to interact with the speakers and to pose questions and and comments to discuss directly the specific contribution. So after that, we'll have a short break, and there will be a demonstration, which again, it will be a live demonstration for us in Zoom. Of course, as the authors will tell you, there will be the opportunity to try it, but with a HMD or something at home in an asynchronous manner. Okay, so after this short presentation, I would say that let's begin with the first speaker of this workshop. So please, the invitation is for Mauricio.
That's me, yeah.
Fantastic. So you are the second author of this contribution. I will stop sharing my slides. So welcome to CIVE 2022, and please share your presentation, and the floor is yours.
Thank you. Okay, I'll start sharing here. 2 seconds. Oh, it says host disabled participant screen sharing. Could you
I need to, exactly.
Yeah, you need to allow me. Thanks.
Exactly. More make co-host. Okay, so now
Let me see.
You'll be able to share the screen.
There you go. Can everyone see the presentation?
Yes, definitely. If the audience have some questions, please use Discord, or even during the presentation. So we will also collect the question and comments there. Thank you.
Yeah,
Mauricio?
I have it beside me, but I'm not sure if I'll be able to look into everything, but I'll try my best. If not, at the end, I'll answer the questions.
Yeah. Sure.
Perfect.
Thank you.
So hello, everyone. My name is Mauricio Flores Vargas. On behalf of my colleagues Lauren Bock and Rachel McDonald, I'm happy to be here presenting our poster in the effect of spatial audio on the virtual representation of personal space. So auditory feedback is an important element in the perception of one's surroundings. Sound transmits different types of information, such as emotional expression, localization information, and environmental cues. Therefore, it impacts how we perceive and interact with our surroundings. Various studies have demonstrated the strong influence of audio in immersion and presence, but when it comes to interaction, research has mainly focused on the visual and tactile feedback And there is a lack of it in how audio feedback influences interaction in virtual reality experiences. Although it's been demonstrated that the presence of auditory stimuli impacts personal space in the real world, there is no prior study on its influence on the maintenance of personal space in VR. And to this end, we have designed an experiment to begin to uncover the effects of auditory feedback on the preservation of personal space in an immersive virtual environment. The auditory system enables us to perceive stimuli and events in the environment, even when they occur outside our field of vision. Not only it provides us with information of objects and entities in our surroundings, it also provides us with contextual information about them, such as their material, size, location, movement, etc. One of its primary purposes is to serve as a warning mechanism, as it can elicit emotional responses, which then provoke a reaction on the listener. For example, moving away from a sound in case of danger, or closer in case of an enticing emotion. Sounds perceived in the near field, or those that happen under 1.5 meters from the listener, can induce more intense emotion responses, especially when they are perceived as approaching, close, or behind the listener. Finally, sound localization refers to estimating the spatial relationship between the listener and the sound source, using a set of perceptual properties that enable the auditory system to calculate a sound's particular angular position and distance. This estimation is determined by combining auditory cues such as interaural time and level differences, amplitude, and monoaural cues that result from the listener head-related transfer function. Besides, sound localization also benefits from other acoustic phenomena such as early reflections and reverberation. It is well established that spatial audio is an essential component of interactive media such as video games and 360 videos. So, personal space. Personal space refers to the immediate space around the body in which we interact with external stimuli. It determines our interaction with the world around us and our feelings about the environment. Personal space can be divided into different categories. The first one is interpersonal space, which is the special distance maintained between ourselves and another person. So it is an essential element of social interaction, as it is emotionally charged and it incites discomfort when it is invaded. The second one is peripersonal space, which refers to the cognitive mapping of the near space around ourselves, which perceive as reaching or grasping distance. And it extends or contracts contextually as interpersonal space does. As demonstrated in previous studies of experimental psychology, sounds affect the representation of personal space and provide emotional information essential for its representation. So, spatial audio has a promising potential to heighten the awareness of personal space in VR. This study attempts to understand how spatial audio affects the virtual representation of personal space by exposing participants to visual and auditory feedback and reporting on interpersonal and peripersonal space. We believe that the spatial audio will provide important cues about the location and distance from the approaching agents, and will either cause the personal space, to expand or contract. And well, without the inclusion of spatial audio, there wouldn't be a personal space representation from behind. So we expect that the shape of personal space will differ when auditory feedback is present, and it will allow us to render a continuous ellipse of personal space around the body, as it actually happens in the real world. So how we design the experiment? The VR environment has been designed using Unity game engine, and it represents an art gallery with paintings and decorative elements, which contains 4 doors in the front and behind the participant. The spatial audio is implemented using Oculus Audio Spatializer. we model a room, we model the room's acoustic response using the audio propagation feature, which allows us to design a response based on the room's geometry. And further detail has been achieved by assigning surface materials with distinct sound reflection properties to the walls, the floor, and the ceiling. In addition to the early reflections, late reverberation, in addition, the early reflections and late reverberation and attenuation features, including the spatializer, are enabled to provide further direction distance cues and create a more realistic environment. The agents in the experiment emit common bodily sounds, such as footsteps and breathing. Using different audio source components, each sound has been attached to the agents in the respective places to match the agent's animation, direction, and distance. This means that we put footstep sounds in the feet and breathing in the head. As it is widely recognized that sound externalization increases with sound source laterality because it provides clearer ITD and ILD cues, participants are approached from the front and the back at 45-degree angle. For the sounds, we use a set of dry monophonic audio samples for each of the agent's sounds. They are triggered randomly to reduce repetition, and in the case of the breathing, they loop seamlessly. The experimental design, well, the experiment presents two conditions. One block of trials requiring users to respond to auditory stimuli, and the second block is without auditory stimuli. And then each block involves two sets of trials. The first one is to measure interpersonal space, in which participants will report comfort distance. In these trials, a virtual agent emerges either from the front or the back doorways, and participants are asked to press a button when they become uncomfortable with the avatar being in their personal space. The second type of trial is to measure peripersonal space, where the user will be asked to respond exclusively to a tactile stimuli. And in this trial, participants are asked to press a button when the tactile stimuli is fired. This happens when the agents reach one of 5 distances from the user, some of them within and some of them outside personal space. So let's see, here's a small video of the experiment. Yeah, okay, that's it. Let's continue. So open questions. We have identified an issue with the current design of the experiment related to the use of generic head-related transfer functions for sound localization. It is well recognized that using generic HRTFs comes with several drawbacks and limitations related to sound localization, accuracy in binaural rendering. However, creating individualized HRTFs continues to be a limitation due to the technical, economical, and time constraints involved. For this reason, we are considering the implementation of a sanity check pretest in which participants are required to localize several sounds at different angles and distances to determine the efficiency of the generic HRTF in the participants. So basically, if the participants cannot locate the sound within a control range, the experiment results will be discarded, as it is likely that the generic HRTF employed is not a good match for them. Good, this concludes my participation. Thanks so much for your time.
Thanks a lot, Mauricio.
Well, thank you.
And the audience has the audience questions, or I don't know. So need to check the Discord channel, but we can also chat here together.
Yeah.
For sure. I have.
I've got a question.
Great.
Right, so you said that you modeled the room reflections and the reverberations. Was that the virtual room, or was that the physical room that the person was in?
No. We didn't model the physical room. There's no physical room. It's all about the virtual experiment. So we used the Oculus Spatializers has a feature in which you tag all the meshes in the room, and it calculates the later reverberation and reflections out of that measurement of the meshes.
Awesome. Thanks for the answer.
No worries.
How about what sort of factors go into how convincing like the individual user experiences the head-related transfer functions?
Can you repeat the question again, please?
So what might make a person like individual experience of the head-related transfer functions? Why would one person find that more realistic sounding than another?
Oh, right, yeah. So as we know, head-related transfer functions mean each one has one of them that is basically modeled after our chest, our head, our pinna, and our ear canal. So generic head-related transfer functions are being made for measuring a lot of different head relations of individual persons, and they have created this kind of generic one that kind of seems to match a lot of persons. However, there's persons that have different physical attributes that just for some reason, a generic one wouldn't actually fit them so well. So that's still kind of an ongoing issue, I'd say, I suppose, in sound design, that to create an individual one, it's very complicated. So the majority of persons are stuck with using generic ones, but that means that they not always work as good as they should for us. So for these reasons, that's why we're doing this sanity check, just to make sure that the people that is involved in the experiment, or the data that we're going to actually consider in the experiment, it's actually from persons that this specific transfer function works for them.
Cool.
I hope
Thank you.
This replies the answer.
Yeah, you even ended up answering my follow-on question, which is whether or how difficult it is to create a transfer model for like just an individual.
Yeah, it's quite complicated, the setup. There's different ways you can do it, and there's been different approaches. I think it's very much an issue that it keeps continue to show, and there's a lot of experiments trying to figure out how to make it super reliably and fast and cheap as well. So I'm not sure how long was it, but I read an experiment. They were trying to use even RGB cameras to take pictures. So then from those pictures, that kind of 3D images, try to model personal head-related transfer functions. But well, so far at the moment, I think it continues to be an issue with audio. Yes.
Thank you. Beside the personalization, as far as I know, Oculus uses a near field HRTF in the very short distance, and I would expect the switching between the HRTF functions from far field to near field. So there might be an issue as well during that switching, that it may suddenly sound, I don't know, unnatural or something. So it's worth checking also that direction. But very interesting research. I think thinking that all objects or interactions are within the periphery, I think it's surprising that nobody looked at that, and you're doing a very nice job.
Thanks so much. Yeah, one of the reasons we chose Oculus, the spatializer, compared to different ones in the market, such as SteamVR, is actually that they have the near field reflections at the specific HRTF. It's a brilliant idea to check just exactly how the change happens. Because the reason we're using it is because of the rendering in near field. Thanks.
We have another raised hand, but also there's,
Hey.
if you would like to, if you would like to tell the answer directly here, because probably I noticed your question in Discord channel. So please feel free to answer here directly.
Which one? The one in admit part?
Yes,
Yeah.
that's mine. Yeah, thanks for the presentation. So I'd just like to know if you looked at participant sort of experiences on maybe immersion, how they felt using questionnaires or anything like that, or even unstructured interviews. Did you ask them how this experience affected them in terms of the feelings of their the different personal spaces that you've described?
Yeah, we have not included any questionnaires about the experience or how they feel about it. This experiment is pretty much based on previous experiments done by my colleague Lauren Book. And so we're basically just taking her version of the experiment, which didn't include any questionnaires, so as far as I understand, about how they feel in the experiment. And we just have added into it the element of the spatial audio to, well, as a novel thing to see what are the results with it. Yeah. So no, we have not. No worries.
Yeah, I have also some questions for you, because this topic is quite interesting for me. I started to use spatial audio in determining the peripersonal space modulation back to 2016. So it's really interesting, and I'm very happy to have a similar contribution here in CIVE this year. So Timur raised a very important issue regarding the near field acoustics, and I was wondering about the pre-screening test you perform. How many distances, if you are you checking the distances, are you trying to identify underestimation of distances in your, let's say, it's evaluating the interaction between the listener and your realization system. I don't know if I was clear.
That for the pre-test that we're going to do at the beginning?
Yeah, exactly. How many distances are you tested, or are you testing different distances? Probably is the right question.
Yeah, we haven't actually narrowed down which one we haven't really implemented it yet. This was something that arose not long ago when we were talking about how to work around the HRTF that everyone knows it's an issue. So one of the things we considered first was based in a paper about training the ear, the plasticity of the ear, to be able to get more accurate responses by training the listeners to kind of hear with a specific HRTF. However, we are not very convinced with that. So yeah, so far we haven't narrowed down which type of test or how we're going to conduct the test, the pre-test, to evaluate if the HRTF works or not. Obviously, from other experiments that I've read about externalization, will have to be something about different distances and at different angles. And obviously, one thing that would be interesting to do, and we've thought of it, was doing it at the same distances that we use for that they are used in proxemics for near field for personal space, for peripersonal space and personal space. So proxemics have already estimated some distances that are the ones we used for the for the tactile feedback to trigger. So far, I think we'll be using the same distances to do a pretest, and obviously angles as well. Commonly avoid kind of confusion and avoid areas that wouldn't be a bit tricky for us. Yeah.
Okay, thank you. But could you spend some words, more words on the tactile feedback, because because it seems like a really important part in the interface, or at least in the experimental protocol for sure.
Yeah, so the tactile feedback is to measure peripersonal space. That is one of the blocks that we want to be measuring. So basically what is happening is that the agent is walking towards you, and you don't have to press when you feel uncomfortable or when you're not feeling uncomfortable. You have to press a button when you feel the tactile feedback. Exactly when it fires is when you are supposed to press a button. So this tactile feedback is fired at, I'm not sure, I think it's five different distances. It's 0.75 centimeters, 1 meter, 1.25, 1.45, and 1.85. So that means that some of those tactile feedbacks are triggered outside what is normally the peripersonal space, and some others are triggered when it's inside the peripersonal space. So
okay.
That's how we're doing it. The logic is that when the agent is actually in your personal space, your reaction is quicker.
So is it the Serino and et al. Protocols? Do you know it's the one that the most common in protocol in an audio tactile protocol? Is it the one from Serino and colleagues? Just a curiosity.
I'm not sure.
Oh, Maurizio, I can answer for you.
Yeah,
it is the Serino protocol.
Okay. It's the Serino protocol. Okay, so the trajectories are straight, so fixed directional of arrival, but the trajectories of the agent is straight following the trajectory. So no I would say it's also the velocity is constant, isn't it?
It is, yeah.
Okay, so yeah, thank you for also this useful details. And that's, if anybody has other questions, I have another one, which I'm quite curious about, the design choice of a room. So basically, you know that externalization has a big impact on this kind of measurements, and the externalization, of course, is closely related to the reverberation, so the direct to reverberant ratio. So I guess it's quite an important parameters for in designing the experiment. Do you have some insights for us, or
Well, let's see, let me think of this. Very good question. The room, it's just based really on an art gallery. So we just wanted to model a space that is a public space. In regards of how you call it, the relationship between direct and light reverberation. Obviously, we wanted a room that it was dry enough for us to be more influenced by the direct sound rather than the reverberation. And that's also why we also chose the mesh of the rooms. You can tag different materials, and that's the reason we didn't use very reflective materials as well, because obviously the sound is way more diffuse, and it's actually sometimes harder to localize the sound sometimes.
Okay, so I can ask many questions because it's something that I worked on quite deeply. So I was just wondering about the selection of the for instance the absorption coefficient, because you can put any. So you have plenty of variability, variables. So this is why I asked why exactly those values. So yeah, just maybe you can think about for potential reviewers. And yeah, and if you need an help on HRTF individualization, yeah, drop me an email, because I usually try to make HRTF personalization practice, and without considering many very resource intense resources. So just
thanks to know. Thanks so much.
Help.
Yeah, it would be great. Yeah, thanks.
You're welcome. Any other questions, comments, or yeah, I noticed another Discord questions from Amit.
Yeah, did you explore?
Yeah, exactly.
Did you explore audio only condition? Yeah, well, pretty much there's an audio condition when it's actually basically coming from the back. So yeah, so that's why we cannot not single it out, I believe. But
okay, but you are still the participant is still perceiving the visuals, right?
No, well, when it comes from the back, from the back, there's no visual representation.
No, but you are immersed in an environment with visuals.
Oh, okay.
I
understand the question. Like with no visuals at all.
I guess this is yeah, exactly.
Yeah, okay. I understand the question. No, we are not considering that as a condition. No.
Okay. Thank you again, Mauricio, for your presentation. And yeah, anybody else yeah, with comments and questions? Otherwise, I thank Mauricio again for his nice presentation. Very interesting. A lot of complexity in your experiment, I feel. And yeah, yeah, because we didn't comment about the attentional bias with in the multimodal stimulation is something really difficult to handle in 360 degrees of attentional let's say potentiality, I would say. So thank you again. And so let's move to the next presentation, which is the one from let's have a look at the program. Designing sound synthesis interfaces for head-mounted augmented reality. I don't know if it will be the presenter. Oh, Ying Chen. Am I correct?
Yeah. Yes. Hello.
Hello. So, sometimes I'm right with the pronunciation of names, but it's not
It's fine.
okay.
You're very correct.
Okay, so please, if you want to share your presentation, I will leave the floor to you.
Yes. Let me bring up. All right. So I think I'm, as a participant, could not share the screen.
Sorry, you're right, because I made co-host Mauricio, but not you. So my fault. Here we go.
Oh yeah. Cool. Yeah. Are you guys? Did you guys able to see my screen? Are you guys
Yeah. Perfectly,
cool.
perfectly.
So I think I'm going to start. Just adjusting. Hopefully this. Cool. So, hello everyone. I'm Michele. I'm here to share my work, designing sound synthesis interfaces for head-mounted augmented reality from the Australian National University at Canberra. In our work, we created 3 different interfaces for a sound synthesis to explore the design space of musical interface and expressions in head-mounted AR system. We're also interested in the freehand gesturing that this particular interaction, which is enabled in this system, considering how it could affect or be beneficial for the NIME, new interface for musical expressions, design and practice. There have been various applications, musical applications created using AR for sonic activities. Early applications such as Yummy or the Author's AR here. These systems are designed as a combination of physical objects with the digital software system for music creation. The physical part is used as the input control of sound by the tangible objects representing the music notes, music tokens, and the software system, which is then responsible for the actual generation of music based on the arrangement of these physical music tokens. The highlight of using AR here is, well, that it connects between the digital and the real world by attaching a sonic layer to the physical objects. It also takes the advantages of the visuals in the AR system as a supplement for the information, so that the experience of music and music making becomes multimodal. More recent works use head-mounted displays, which can support a better visual experience given the large field of view in the AR environment, as well as the interactions which transformed to the freehand gesturing or physical controllers, so that you won't be limited to a physical interface or desktop when you have to interact with these, when you need to interact with these sonic components. So several noted works here, such as the sonic sculpture or the augmented piano, they either experiment the sonic interaction with the virtual objects, or having like additional visuals to have a better piano performing experience. So from the above examples, we can see both the novelty and the benefit of using AR as a medium for different sonic activities or sonic expressions, particularly the more immersed experience, which is enabled using the HMDs, as well as the more advanced freehand gesturing. So we thus started to wonder what could be a genuine interface, which is specifically for music in expression in head-mounted AR. I'm sorry for the background, it's very early in the morning. So we took the empirical approach, started by actually creating, like experimenting several design ideas of interfaces that could possibly suit in a Microsoft HoloLens. Our first interface was quite intuitive, inspired by modeling a physical sound synthesizer interface. From the video here, you can see it is composed as a cube, having one face laying out the sound control of all sound parameters of a frequency modulation synthesis. This interface can be moved around, so you won't be limited like at a certain space or even at a certain height when you're trying to interacting with it. Although the design of this direct control of tuning different sound parameters seems to be familiar and straightforward, when we actually try out this experience, this interface, we actually, we found the latency and the inaccuracy of the hand tracking due to the headset, so which make the whole interactions a bit laggy, and also disrupted the real-time music making experience. So we found this prototype is not that good or easy to use. To solve the issue, we decided to reduce amount of the subtle or the complex interactions which we had in the first one, of like adjusting the sliders.
Yinchen?
The interaction,
Wait.
which is done by moving the
Sorry,
objects.
I just lost
Yep.
your 20
Audio.
past. Yeah. Also the video. I don't know if it's the case also for the other people in here. So it was just me. Me too. Okay. Thank you for the feedback. So could you go back at least 20 seconds?
Oh yeah.
Thank you.
Yeah.
Thank you for the feedback.
So it should be. Oh,
No. This slide it was perfect, but after
yes.
This one. The second one.
Okay.
The second. Yeah. But not entirely. So I wasn't sure about the exact point, but you can start from. Yeah. The beginning. Thank you. The beginning. Someone told us. Thank you. You can. Okay. We lost you again. We still continue having network connection troubles. Yeah. No, she's freezed, entirely freezed. Okay. I hope she will try to rejoin the workshop. Okay. Here we go.
Sorry, guys. I think my internet cut off.
No problem. It's important that you are here again with us, and you can start again when you were exactly at the beginning of the
second one. Yeah.
The second one. Yeah. Thank you.
Yes. So yes, we're trying to reduce the issue that we had in the first prototype, which requires very subtle and complex interactions. So how we did this time was we decided to use more abstract and simple interactions by moving the objects over space, either horizontally or vertically for sonic changes. From the video here, you can see that there are two cubes. They are still representing the FM synthesis. One represents a carrier and another one represents the modulator. So you can move the cube using far-reach interactions, either up and downs or left and right, and it has the responded design of the change for the parameters of frequency modulation synthesis. The overall experience of this prototype was pretty good compared to the first one that we found we do not need to spend lots of time adjusting the sliders. But we do found this interface is pretty simple from music-wise. It does not provide much flexibilities for performers to experiment different sound. But we really like the ideas of having sound cubes, having the sound represents other cubes. So with these reflections in our last design, we decide to have more cubes, and they are representing different nodes. We arrange them in a cylinder surface so that you can it can be accessed from both sides. You can either, like the video here, that play one note, or you can play notes, multiple notes together using the fingers like accessing from the both sides. By these interactions, yes, no doubt it has a better experience of the issue that we found in the first one, and also have more music flexibilities. Regarding the technical development of these interfaces, in general, we have these interfaces designed and developed as individual game objects in the Unity, with the sound component attached in that object. So here is an example of the sound component. So we used this Unity synthesizer toolkit. Essentially, they are just a bunch of basic scripts of synthesizer, and you can easily connect them each other so that it can create certain sound effect. And it is quite lightweight too, so you can write your own script, and it can also do something with the sound component here. Reflections. Yeah, several reflections from the design development of our interfaces. First, from these all prototypes, we experimented different interactions, which is enabled in the Microsoft HoloLens. We both see the advantages and the disadvantages. For example, like the first one, which was, already designed, like trying to model how we would normally interact with a physical sound synthesizer, but we found that this kind of interaction did not actually work in the head-mounted AR system. But rather in the last prototype, the finger interaction, which we never, not very like easy, popular to see in the physical sound synthesizer, but it's really like comfortable and easy to use in this AR environment. Second, when we were designing these interfaces, we start to think about or trying to distinguish the notion of design for sound control or design for sound expression, which is proposed by Dobrin and Kopman in their paper of the IEEE musical expressions with new computer interactions. It is reminding us whether we are only designing or developing an interface only purely for the functionality, or it should or compacts more other qualities such as aesthetics, given NIMEs are used or designed for music performance. Future work, I'm currently still improving the prototype, the third one. I am trying to put more notes there, and it has a more better arranged interface so that I can provide octaves. Also, I want to have a sequence there so that it is really a proper product or artifact could be used in live coding, live performance. I'm thinking about how this interface in the AR environment can be accessible for other people in the reality. Yeah, cool. I think that's it. Thank you. Any questions?
Thank you so much. Thank you so much. Very interesting presentation and highly interested topic. Because yeah, the prototyping phase is all the time. It's really important in any design process, and it's yeah, it's really nice to see different iterative prototype or different, let's say, strategies for sonic interactions. Any questions from the audience? I have to check the Discord channel.
I do have one, if that's okay.
Yeah.
Sure.
Hi. So thanks for the presentation, Michele. That's really nice.
Yeah.
I like the idea. I was
Thank
wondering,
you.
so when you were showing the cube moving in space, if I got it right, there is some kind of mapping between the way the parameters of the cube, so how it scales and how it's placed in the air, etc., and the sound that you're creating. And I was wondering, how did you create the mappings, and if this was in a certain way explained at some points, and like if a new user would come to that, would I know what mappings are between, I don't know, the scale and the sound or the position, etc.? And is this something that you can control easily in a way?
Yes. So he's the actual poster of this. Can you see that? So it's quite simple, to be honest. So if you move that vertically, it's changing the pitch or the note of the modulator. And if you zoom in or zoom out the size of cubes, it's changing the volumes of the sound. And horizontally, it's when you move it around, it actually changes the pulse width of the LFO. So you can see you can hear the frequency is changing, like how it changed. Yeah. So, but I mean, Bruno, you raised the very important questions on why I was thinking during my design on what is actually the mapping of the sound with these interactions on the interface, and how the other users could notice, or whether they should how they feel, or whether they feel comfortable. So when I designed this interface, I started with the very simple idea, having the very simple FM sense, and I chose the component which is you can find the sonic change easily, and that is then mapped to the interaction part, if that makes sense. Yes, but I mean, because this is like only a prototype, you can we can definitely try different parameters that we can tune. Yeah, and see just experiment different ideas. But one more comment, as you mentioned, whether the participants can be used to this kind of thing. I think it's quite important when you design a NIME that it is not that obvious for the user to notice how it will change, because there will be just an interface, right? Like press a button or just a slider, but also not too complicated. That is, you can't find the clue. So it's something like found it in the middle, that like there's some space for us to try, and we found interesting, and we got used to it, and yeah, makes sense. Or yeah.
Yeah, and to me, I always wonder in those cases, what is the controllability of that? In a sense that if someone trains with the system for some time, are you able to really play it as an instrument? And is this something that you can really control in a way at some point? Because I can definitely see someone just playing with it and, you know, trying some sounds, but at the end you're just exploring more than actually trying to find something exact in a way. Compared to someone who would be like, okay, I want to create this thing that I have in mind, and, you know, being able to control that. And I feel like you could do something like this. I just wonder, like, how of an expert in a way you can be in using such tool.
Yeah, so I think that's what we keep in mind, particularly in this field when we are designing new interfaces, whether they're only just for interfaces like buttons or controllers, or there's some like more artistic piece. Yeah.
Yeah, that makes me think of also people using gloves to also do this kind of things, and at some point you can really like control that in a very kind of exact, precise way, in a way that is like you do what you want to do instead of just exploring it. And yeah, I really wonder how people will use that. So thanks again for the presentation.
Thank you.
We have a couple of questions in Discord. So Amit asked, did you conduct any formal or informal user studies looking at usability? And then there's another one. Given that musicians tend to spend quite a bit of time working with composing, do you think the mid-air interaction you are shown can be fatiguing over long periods? So, and it's one person with two questions, and we have another two questions. Yeah. So if you want to ask to this one, it would be nice.
Yes. So the question regarding the first question raised by Amit, yes, we actually did a informal user success, but after the submission of this work in SAFE, yes, and we took the autobiographical approach. I'm not sure whether you know much about this. So essentially, is myself as actually the first person approach to tested the prototype, which is myself as a composer. Yes, and I'm thinking about future. I'm thinking about having a more formal user studies in the future after I polished the prototypes, but also because in the January, because of the Omicron in Canberra in Australia, we were not that able to do the formal user study, but definitely I would like to try. I mean, I'll definitely do a formal user study in the future. And the second question, yeah, do I think the media interactions action can be fatiguing over longer periods? Yes. So from all these three prototypes, I found the first and second one, they are more fatiguing compared to the third one already. The reason is that because these interactions requires you just keep your arm holding up, and it does not give you much flexibilities of like having very subtle interactions. And this is really tiring. Like I even felt sore when I was doing the composing by myself, like within a 3 minutes period. But for the last one, it's better because we do not need to keep the arm holding up like here, but here is like more more comfortable, and using the fingers, which actually gives you lots of exercises while you are playing with the interface. So the fatiguing is less, and I'm quite confident for the last one. Yeah, that can be used for a while. Yeah. Did I answer your questions, Amit?
It seems so, at least.
Yep. Yeah. Thanks.
Yes.
Thanks a lot. And yeah, I know what it is. We haven't been able to run user studies here in New Zealand as well, because we are going through our wave right now. So it's fine.
Yeah.
Yeah.
Yeah. Maybe
Thanks
try. Yeah. Sorry. I'll just maybe try the autobiographical approach. I feel like the first person approach is, well, I mean, I feel like at least useful in my research, because I'm designing it for myself, and given also, the pandemic. Yeah.
Yeah. Yeah. Cool. Thanks.
Thanks. We have another question from Nikki. For the direct control interface, was the sound produced using programmed samples or generated live with DSP?
Yes, so it's actually like real-time generated using the disunity synthesizer toolkit. Yeah, it's a script like written for the actual real-time music yeah, signal processing in the Unity.
Nice. And then this is something connected maybe to the informal studies of the previous questions.
Yeah.
Have you think about letting novices or non-musicians to try your prototype? It's like I was thinking about the usability, and then also could it be cooperated by several people to compose music at the same time, so in a collaborative way? Have you ever think about it?
Yes, so yes, so well, like yeah, the first question, Jiali, yeah, quickly, yes, I would think about letting novices and or not musicians to try my prototype, because I mean we design the instruments not only for the professionals, but also for novices that they can play. Yes, and the second one, yeah, that's a good idea. I was actually thinking that maybe whether we can deploy to several different Microsoft HoloLens, and for sure there's more works need to be done to how to do the real-time like transaction teleport and see how it works.
Thanks a lot. And then I have another curiosity, because in the paper you showed us that you developed everything in VR, and then you also in the slides you showed a video in AR. So I would like to ask you what's the I mean, did you check or at least consider the peculiarity of being in a augmented reality context rather than a virtual reality? What's the difference for the experience, for the sonic experience?
A good question. I also thought about this when I was designing this interface. Well, to me, for AR, for sure, the advantage it's accessing to the real world, and you can communicate with the real world with the participants or other people's. And yes, and in VR, it's fully immersive, and yes, so like I mean, from the AR part, like I mentioned before, in the future work, I'm thinking about how it can be better aligned with the reality. Whether we can have like Jiali said, whether we can have multiple people playing that together. That's the advantage of using AR here. And for whether there's difference between sonic experience and like between AR and the VR, it's an interesting question. And in my opinion, I feel like because we're talking about sonic design, sonic experience, the main channel is for audio. Visual is used as supplement from my perspective. Well, if we put this into the VR context, I wondered whether we will be more actually overwhelmed by the visual channel. And I mean, for sure, it's for different purposes. And yeah, and see whether it is aligned with our research goal. Yes. Well, to me, I mean, more into the AR part, because I feel like, yes, I love the communication with the physical world and the opportunities there. If I answer your questions, Michele.
Yeah. Partially, I would say yes. Just a suggestion for the future, because the power of augmented reality is, as you said, the connection between the real and the virtual. And in this case, you are not exploiting the full potential at all, because you are considering the visuals as like a common ground to communicate during the creative process. So trying to incorporate, for instance, sounds, real sounds from outside, inside the composition, or at least interact with external sounds and the compositions together will strengthen this this connection. Otherwise, maybe the fatigue will be much higher with considering these two things separate. Just a comment and a suggestion for the future. I'm pretty sure that it's technically even more challenging, because you need to collect the sounds from outside, from the real, and inject to an audio pipeline in real time with your composition. So it's really challenging, but as far as I can tell you, it could make the difference in terms of sonic experiences in augmented realities. In that case, it will be a really an augmented sonic experience. Yeah, just comment from that. Any other question, comments? I don't see any other new questions for you. So,
Michele, Discord doesn't work for me. Probably different user credentials. But
okay,
I was also thinking in terms of your question, but slightly different. So when we look at the affordances of augmented reality, as demonstrated, for example, in Magic Leap, Shigeru Ross video, or mobile AR as well, that is, the environment becomes part of the interaction. So we can easily detect surfaces around our main focus and then use that as an interaction modality as well. Shigeru Ross really demonstrated that with this ghost appearing and interacting with the environment itself, or making a portal or something like that. So there are visual modalities, yes, but they might help with your main concern, not a controller, but an expression mechanism. So are you also incorporating this, planning to incorporate these visual affordances?
Yes, can I confirm? So your question is whether I can see the visual parts, the like more formal works, considering the visual aspects in my work.
Yeah.
I haven't thought that much, but I would like to look into that directions. I feel that definitely makes sense. And interesting to look into.
Interesting. Thank you.
Definitely, yeah. The points of view are different, and also the potentials are really high. So yeah, we potentially we need many prototypes, but yeah, another research direction could be how to get this and provide an automation of prototyping things. Yeah, definitely a good point. And just thinking about the infinite ways of exploiting the augmented reality information. So thank you again, Yin-Cheng, for your presentation, and let's move to the third one from Jali. Welcome, at least visually, and Jali is presenting a work with Nick Bryan-Keynes entitled Kyoli. Probably it's not the right pronunciation, you will correct me. Accessing traditional Chinese musical instruments in VR. So please, I will let you present the rights for presenting.
Yes.
Usually make co-hosts. Okay. So
okay.
You are you have the opportunity to share your slides.
Yeah. Just a little. Oh, sorry. Just a little.
Yeah.
Could you see my?
Yeah, definitely. Thank you.
Hello, everyone. I'm Jia Li. I'm from Media Arts and Technology Center for Doctoral Training, Queen Mary University of London. And I'm talking about my paper, Qiao Le, Exercising Traditional Chinese Musical Instruments in Virtual Reality. In this paper, we present the design of a VR system called Qiao Le, in which people can exercise and learn about traditional Chinese musical instruments. And also we undertook a user study of Qiao Le to explore the use of embodied interaction and gamification for access to musical intangible cultural heritage. I think the result of the paper could support VR application design for musical ICH and instruments, also can support using embodiment interaction and gamification in virtual reality. So first of all, why we need to design the VR system for people to access the musical intangible cultural heritage, because there are lots of barriers for the non-experts to access. First of all, the content is often from several centuries ago, which make the cultural context difficult to understand. And also, musical SH is usually community-based and location-specific, making in-person access potentially costly in terms of time and money. And also, it can be difficult for academics and experts to convey the richness of culture, art and daily practice of the populace to useful visitors. Now, there are lots of popular methods of exercising the musical SH for the non-experts. For example, they can go into music concert and festivals and instrument museums and exhibitions, also using some mobile applications, website and online exhibitions. But now we still finding more conventional approaches, such as using the immersive and embodied nature of the virtual reality. So why we need to use VR to access the musical SH? Because we think VR can help connect with the physical world and virtual world, and also motivate and support visitors to participate in the process of making and creating meaning by themselves. Besides, some case studies show that when designing like interactive systems, the use of embodiment interaction and the gamification have many benefits. For example, embodied interaction can help people understand more perception of the ICH by physical touch, and the gamification can improve learning and enhancing the positive experience and make them more enjoy in the process of accessing the musical ICH. So we suggest that embodied interaction and gamification can help people to access this, so to explore the user experience and the usability of embodiment interaction and gamification for accessing musical SH. We built a VR system using Unity engine called Qiao Le, with 3 different models of interaction: the exhibition mode, the open interaction mode, and the gamification mode, and tested this in a user study with 3 different traditional percussive Chinese musical instruments. So, so this is the exhibition mode. In the exhibition mode, people can't really touch the instrument, but only can see and listen the audio of the instrument and watch the video from like the experts. And in the open interaction mode, they also have the same environment, but people can feel free to play with the instrument by themselves and create some music by themselves. And in the gamification mode, we let them to finish a playful task and finish the task in the process. They need to find the 5 notes from the audio and repeat the melody. And for the user study, 24 participants joined the study. We used the Zoom to manage the communication between participants and researchers, and also we conducted the user study online. All of people were divided into 2 groups to experience 3 modes in different order. And we collected the data by 2 ways: questionnaire to assess a set of user experience factors and the usability of VR system. You can see the questions from the questionnaire. And also we have an interview to know like why people choose these answers and how they're feeling about the VR system. 2 sets of analyses were carried out on the questionnaire data. The first is comparison of the results for each interaction mode for all participants to examine the effects of embodied interaction and gamification. And another is comparison between the results of 2 groups to identify any ordering effects. So for the figure 1, this is the result of the presence, enjoyment, expectations, and the usability. And the second figure is the proportion of the correct answer of learning performances from correct and incorrect answers. And the third figure showed all significant results for questionnaires responses by interaction mode. So we found there are some significant results in presence, enjoyment, and the knowledge. So for the quantitative results, we found that participants reported feeling differently about others people's presence in question 2 and question 3 in the 3 different modes, in the 3 different modes, with a lower agreement on the exhibition mode and higher agreement in gamification mode and open interaction mode. That indicates that participants feel more immersive and realistic in gamification mode and open interaction mode rather than the exhibition mode, because both of these modes they can really interact with the instrument. And also there was a significant result effect in 3 of the 4 enjoyment questions, with gamification showing the most agreement with question 5, question 6, and question 7 compared to other modes. Like people more enjoyed in gamification mode, and the people want to repeat the gamification mode than other 2 modes. Also, gamification mode is more interesting than other 2 modes. For the learning performances, only the question about the date of the instrument shows significant effects between 3 interaction modes. So people answered the right answer, right date time of the instrument after experience the open interaction mode, and rather than exhibition mode and the gamification mode got the lowest correct answer. Then we using the semantic analysis to analyze the qualitative data, and 3 main themes were identified, and 11 topics concluded from this data. First of all, most of people think the feeling and experience is really fun, interesting, and great, and they want to play with it. And the 3 instrument models are very detailed and clearly, so they think it's really immersive. And most of people think it's just like true in a real museum. And they don't need to go other countries or areas and don't buy any tickets for museums, and they can just play with the instrument. So it's really the threshold is really low, but it's not really technologically friendly, because most of users in nowadays, they don't have the head-mounted display at home actually. And in the gamification theme, they think the gamification mode is really guided, because they can follow the guide and understand what they could do about the system. And also there are some challenges and bugs showed in this mode, because sometimes when they hit a certain chain with the mallet, it would cause like some tries at the same time. And for the knowledge theme, they think the text UI could be teach them the history and the background, but it's hard to remember. So it could be improved as a quiz or small questionnaire game to help them remember the background and history of the instrument. And they think it's a good way to learn Chinese culture, because the environment is really Chinese. And also they can repeat how the sound and how the voice sound like for these 3 instruments. Most of people think it's hard to learn the playing techniques in VR, because you can't really find like when you change the speed or when you touch the different shape of the instrument, it should be sound different. But in VR, it's really hard to achieve this subtle effects. So conclusion, we found that embodied interaction can improve user experience of accessing musical SH in VR, and the gamification can improve the user experience positively, because they showed higher scores in enjoyment, presence, and gamification potential to motivate participants learning about ICH. And there might be some ordering effects between the groups. And for the future work, we still find like explore the effects of different forms of the embodiment and the features of the gamification. So in my next study, I will do another prototype and evaluate more factors of the gamification, and whether it have similar results in other musical instrument styles, traditional, also should be found. Okay, so that's all. Thank you.
Thank you so much for your presentation. But just a comment, the video that you showed, did it as audio also, or it was only a video with visuals and that's it?
It should have audio, but it didn't.
No, at least I didn't hear anything.
Oh,
okay.
Yeah,
I don't know if you can. I don't know if you can try again. Maybe there's something more to in terms of control.
Just make sure when you share the screen, when you click share screen, in the bottom you have to share the audio as well.
Oh,
exactly. Yeah.
Oh, yeah, I forgot. Sorry.
Okay, if you want, you can show the video again to the audience.
Yes, maybe I can just show the video.
Or the video only, yeah. but I think it's nice to hear also the sounds in Sive.
Can you see? Can you see the second screen? The
Yeah.
Okay.
Yeah. Yeah.
So can you?
Yeah.
Oh yeah. So it's the exhibition mode, so people can only watch the video. And listen the audio. And in the open interaction mode, they can like and in the gamification mode, they need to listen the yeah. So that's all.
I mean, much better, much better. So I just start with a question. So are you using samples, I guess, or are you procedurally synthesized the sounds from the bells?
No, because we like connect with the Chinese Conservatory of University of Music, and they have a database for all Chinese traditional instruments, and they collected and record this all audio and data and put in a database. So we use the audio from that database.
Oh, I see. So, and do you think that adding some animations could
Yeah.
help in the immersion, because it looks like pretty static? Yeah, it was static also when the first time you showed us, but with the sound is even more static, because you listen to the sound with that dynamics, and you don't see anything happen.
Yeah, that's what I need to improve in my next study. And also there's lots of feedback in my interview, like in a scene, a topic about the feedback is that I need to add the vibration and animation for the instrument. Yeah.
Thank you, thank you. Oh, we have a rising hand.
Okay.
Please.
Yeah. Hi, Jiali. Really interesting work, like Nikki said. Really connects with the music culture. I think I got two questions. The first one, I think, is similar to what Michele mentioned. So, what you have in your system right now is using the audio data, right? Have you considered that? I mean, first, whether if we actually when we're actually playing this instrument, have you considered whether there will be some issues, when you keep playing the samples and the audio will be like clashed or something like that?
Oh, yes. I think I think yeah, I consider about that. But like it is about like a technical problem for me actually, because before I conducted the study, and before my PhD, I don't have any background for computer science or the data programming. So for the Unity, I just found like tutorials how to make people play with the instruments. So I used the sample data. So it should be installed the data, installed audio in the instrument, but also we are thinking about it's really hard to do like the real time, just like the real time instrument, because for different part of the instrument, it should be sound slightly different. Like in one note, they should have like in do, they have do 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 do. I don't know how to say, just but it's what I'm thinking about how to do. But if anybody, if anyone has better suggestion to me or better references, could send to me. Yeah, thank you.
Because I had well, I had experience. I mean, I've been using Unity, and my other works were using the like playing the samples, and I found the issue there because you just use the like dot play, the sample, and the audio quality wasn't very good. Well, it is fine if you only just play, trying like there's an object and you just try to play the audio of that like object. But if it is actually in a like a instrument setting, the keep playing that will actually like ruin the whole music experience, if that makes sense. But yeah, definitely something look into. And sorry, second question, can I just ask something ask some question about your user study? For the questionnaire, are you using the one for checking the immersivity?
No, I have several factors about the presence, enjoyment, and the expectations, and also the knowledge. The knowledge is about did you learn something from the process of accessing the instrument? So, would you?
Sorry, my question was like, so this kind of standards, right, in your questionnaire, like did you have any like references from like existing literature, or like you came up with like them by themselves, and what like goals or properties you were looking to when you were designing this questionnaire for the experience?
Yes, I have several references, and also I like come up and modify them and make them together to do this. So because what I want to test is about the user experience and the user and the usability. So most of questions about these two scale. So.
Yeah, that makes sense. Thank you.
Thanks for your answers. And any other questions from the audience? Yeah, Bruno, please.
I do have one, if we still have time.
Hi.
That's okay? Yeah. Okay.
Yeah, we are, let's say, following the schedule. It's gonna be a break, but we can let's say collect the last questions and then having the break. Otherwise, without ruin the continuity, I would say.
Okay. So first, thanks for the presentation. This is very nice work. I really like it. And I was wondering, so you're using VR and you're making people really like tap on instruments. I mean, really, it's virtual, of course, but do the gesture, and I can see where this can be very tricky in the details of how do you actually recognize the gesture made by the person and how it hits exactly the bell. And I was wondering, I know that a lot of people are using virtual instruments on keyboards, and I wondered if you ever thought what could be the difference between actually interacting with the virtual instruments in VR while seeing it and interacting on it, and using a virtual keyboard? And do you feel that there would be a difference in the feeling of the instrument or the way you would play it?
I think I'm a little bit confused about your question. Sorry. Maybe
That's okay.
Are you asking like why use why design them the instrument in VR?
Yeah, I can rephrase that. What I mean is, let's say I'm looking for percussion instruments. I could be loading virtual instruments on the MIDI keyboard and play them on the MIDI keyboard, and then play with the different parameters there. And you're doing that in VR with the special aspect of it and the visual aspect of it. And I'm wondering if you ever thought of what could be the difference between the two, and what would be the advantage in a way of using VR, or maybe the disadvantage of it. That's a difficult question, right? It's completely okay to say you don't know much about it, or I just wondered if you ever thought about it and started investigating a bit that or not at all.
Oh, yeah, thanks for your question. I think maybe I didn't think about the question before, so I'm quite don't know the answer. But I will check later to see. Okay.
Thanks. Thank you.
Thank you.
Yeah, a lot of food for thoughts, I would say. And then if I don't know if there's any other questions, but I would like also to give a comments to the gamification aspects, which again, it seems sometimes that the level of the advancement of the interaction design with games reaches the desired point, and then you can perform the evaluation studies. So to me, I'm not a game designer, but somehow the flavor is that you build a game. You strive to build a game that is better than a very basic interaction. So I'm pretty sure that developing the gamification aspect will require you more efforts, but it will be really interesting for the community to also to build a more solid background for audio games. So the games with audio. So it just a comment, not having, because it seems from the statistics that you showed that the significant results are the effect of the interaction level in the game, not the game itself. I don't know if I was clear in that.
I understand what you are meaning.
Yeah. So basically, in order to disambiguate and at the end you will have no doubt about the quality of your game, I will suggest you to try to find a robust way to, and also theoretically basis to design the game, right? Okay, just I don't know if anybody the audience agrees with my comments, but yeah, it's just my opinion on gamification, and especially gamification with sounds, which is something really interactive in and we noticed also in your very nice example. Okay.
Thank you.
Thank you again for your presentation. So it's time for break. I suggest to go for the demo session at 10, and also and then after we conclude this nice CIVE 2022. So at 10 with the demo. See you soon. Okay, welcome back. Now there's the time for the demo of this CIVE edition. It will be made by Bruno Prouchard and Donald de Green. Sorry for the pronunciation again. Yeah, you will correct me soon. And the demo is of weirding haptics, prototyping vibrotactile feedback through vocalization in virtual reality. So no, sorry, just stop sharing my screen, and then I will leave Bruno to introduce the demo and the modality used for this remote demo.
You need to enable me to share my screen again.
You are right. Here we go.
Yes. So, I can share this there, and you should be able to see that, right? So I'll start.
Yeah, everything okay. Sorry.
No worries. I'll start with the presentation of what I'll be demonstrating, and then go to the system and demonstrate it. So the system is called Weirding Haptics. This is about prototyping vibrotactile feedback through vocalization in virtual reality. So we'll be talking about vibrotactile experiences in this case. We all know those experiences. We experience them mostly, I guess, daily with phones or smartwatches or anything that vibrates to notify us of something, which could be an email received, a message received, someone calling us, etc., etc. But such experiences can also be used in different contexts and can be used, for instance, to reproduce physical textures with a system like you can see here. So there is a pen, some vibromotors on the pen, and based on where the user is dragging the pen, it will be vibrating in some ways, and that will create some kind of friction, some kind of roughness of the surface, etc., or even smoothness to it that will reproduce certain textures. What's interesting is that in the context of VR, we can also create tactile illusions when manipulating objects. For instance, in this project, pseudobend, the user is grabbing a physical rod, and when twisting or trying to bend the rod, actually the rod is not moving, but using vibrations coupled with the actions of the user, we can create illusions of the rod being twisted, the rod being bent, etc., shrinked. This is the same case with a shoe, for instance. You could be walking in VR, and by putting some pressure sensors below the shoe, when walking, we can trigger some vibrations based on the pressure applied to the ground. And that can be used, for instance, to create some UIs for feet in VR. So by pressing on a stiff surface, we could simulate that the surface is actually deformable, and that would create the illusion of pressing on a button. Or the user could be walking, and depending on where they place their foot, they could have the feeling of pressing different textures, like a wooden plank that might be about to break, for instance. So one challenge of those experiences is to design them. This is quite difficult because we need to couple the experience to the action, and we need to manipulate different kind of parameters. The state of the art, the tools that are accessible commercially now, they mainly have the approach of letting the designers customize, manipulate some parameters, such as the amplitude of the vibrations, the frequency of the vibrations, and then control the waveform of those vibrations based mostly on time and not so much directly linked to the action of the users. This was one example, the Lofelt Studio designing tool. This is another one from the Interaptics, and you can see this is for novice users, people that do not know much about haptics, that might be a bit overwhelming. So the state of the art could be summarized like this. People want to create experiences for VR, but they need to design those experiences on a computer screen and on a working station. then go inside the VR environment and experience the vibrotactile feedback inside VR, try it, and then go back to their computer to change what they were actually trying to do. With Wording Haptics, what we achieved is enabling the designers to design those experiences directly inside the VR environments through their voice. The point being that they can manipulate an object, let's say a door, move the door, and while moving the door, they can vocalize what they want the experience to be. That is, I don't know, I would be doing something like wee, and that would be then translated to vibrations. So the main contribution of this work is the vocalization aspect. This idea of designing in situ, so inside the VR environments, and we are building on direct manipulation techniques to actually manipulate the virtual objects and vocalize at the same time. So we can control the space and time of the experience while we control the way the vibrations are made. Here is an example, but I'm gonna show you this right away. Yeah, and let you see how it looks like. So just before I forget, this is available on GitHub. So if you have a VR headset at home, you can be able to use that. The documentation might not be great, but if you're using it and you want some feedback or you have some questions, please reach out to us. And I'll stop sharing the screen. I'll switch my camera to this one, which would be a VR view. Yep, and I probably need to add myself there so you can see what I'm doing while I'm doing this. So the first thing is to calibrate the voice. So how we control the vibrations, we actually take the amplitude and frequency of the voice and we directly map that to the vibrations. So the first stage, the first step is to calibrate the voice. So I'm going to show you this. I'll just start that, put the headset on. If you have a question or something, you want to interrupt me, please tell it out loud because I don't see anything. I'll be using this microphone here. I guess you can see it. Let me check that. No, okay. There's just a microphone next to me to record my voice. Oh. So here, I hope you can see this. If you're not, please tell me. The calibration is very basic. We just go with a minimal amplitude. So the user has to do a quiet sounds, something like this. This will record the sound and use it as a minimal boundary. And the other one is just doing a loud sound. So what would be the maximum I would use while designing the experiences? Something like ooh. Seems okay. I'll validate this. Go with the frequency. In this case, I have to do a low note, low pitch, and high pitch to again basically set the minimum and maximum for the experiences. So let's go with ooh. So that's it. I calibrated the system. I need to switch to the other scene. This calibration step is very basic, but that's enough for what we need next. That is, okay, this is loading. There we go. So we are in the scene here. There are some objects. Here is a simple slider. I can go here, grab it, and then move it around. Maybe you can see there are some different textures. So we'll come back to that. There are here some boxes to grab, and there's a lightsaber. Okay. So here I'm in the play mode, so I'm not designing anything. I can grab stuff, but there is no design. So I can switch to the edit mode. You can see the non-interactable objects are translucent. And when I do that, then I can press a button right here that will tell me ready to record. And all the actions I'm going to do with the objects, I will have to vocalize the experience I want, the vibrotactile experience I want with this object doing this action, right? So here, let's say I just want, when I touch this small box, it's going to do something. It's going to do some vibration. So I'll just touch it and go for it. Took. Here, it recorded something. If I select the box here, okay, this is very low, so I'm going to redo that. Took. Might be a bit better. It's not. Let's do that a bit louder again. Took. That's a bit better. So here what I'm doing is when I'm selecting the object, we can see that here the action is when touching the object, something happens. And this UI here is showing me this is the waveform of the vibrations. This is the duration here, this 270 milliseconds. And then some parameters that go with this. So here what it means, what I did is I just touch it. So when I touch it, I can feel the vibrations in, there's a mic here. The vibrations in with the box, I can feel that. Okay. What the program did is that there is a special temporal mapping of the action. So when I recorded something, the program understood, okay, what you want is actually something instantaneous. So this is this one time here. That means I touch the box and something is going to happen once, and that's it. If I want to change that, I can. This second mapping means that it's going to play continuously. So if I put my hand on it, this plays and plays and plays and continues playing. So in this case, this is just by vibrations. I can feel some differences in the amplitude, up and down a little bit, but nothing much. And this third one means that if I move with my hands with a different speed, it's gonna alterate the vibration. So the more I move, the more vibrations, the stronger are the vibrations. So if I start moving a bit more, I can feel stronger vibrations here in this case, based on the waveform that you can see. Let's go to this next box, and I'm gonna put that here. I hope it's gonna say no, probably not. So yeah, I'll just go here. So I'm not gonna hit the mic. Let's say that in this one, I want to create the illusion of a rock tumbling inside it when I move it. So I'm gonna press here, ready to record, and then go for this. Tuk, 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 tuk. I'm pressing the recording button, and this should have recorded something. You can see the waveform here showing. This action here means that it's a grabbing action. So it's not just touching, I need to grab the box. And you can see that the system was smart enough that it's telling me, oh, you were moving your hand while you were recording. So we're gonna actually, we're gonna select directly this mapping. That is, if you move with the different speeds, then the vibrations are gonna be more or less intense. So here, if I grab it and I start moving my hands, I can feel with the movement that yes, there is something inside the box. I mean, there's something. It creates the illusion that there is something inside, right? Now, there are some modifiers just below here that can help the user fine-tune the experience. So here, the first one that we call the expressiveness is just a way to contrast the peaks in the waveform. That will put down the quieter peaks and put up the louder peaks. So if I change it here, if I put more expressiveness, in this case, it's gonna increase the peaks, so just make them stronger. I could be adding some randomness to it, so just some noise that will help like create some vibrations around. That might be interesting. Let's say, for instance, in this box, the next one, I want to create some kind of scent feeling when I'm moving the box. So let's record something for that. We can check what it recorded. So that looks like this. It's 4 seconds. Let's grab it. Let's see how it feels. Yeah, there is something. There's definitely something. Here we can, for instance, put a bit more randomness. To add just some randomness to the experience and create some more chaotic effect. That seems to be working okay. The next one, the intensity is basically changing the amplitude, so putting it a bit less or a bit more. And the modulation is to change the frequency of the sound. So frequency can be quite useful. Unfortunately, with those controllers, we cannot control the frequency. The API does not allow to control the frequency. In our experiments, in the paper we actually added another vibration controller, vibration motor here, where we could have more control, and we found out that there are some trends showing that controlling frequencies creates more control on the experience and a better effect. Let me go here. If you have any questions, just stop me, right? I don't see anything, so just shout it. Let's see with the lightsaber something else we can do with the tool. That is, we can add layers together. So lightsaber like this might have some kind of humming feeling, humming experience when we touch it. So let's add that first. Okay, didn't work. So this should, oh yeah, let's print this one. So here the waveform is very small, but there is something. So when I touch it, or here I don't feel it enough, so I'll put a bit more intensity. That's a bit too much. So when I touch the saber, there is a feeling. So you know this kind of electrical feeling that you could be feeling with such a tone. That's when touching it. Now let's create this famous kind of sound that you would have with the lightsaber that would probably feel something with the end. So I'm gonna grab it and go. Stop recording that. Put it down just to see if this recorded this. Okay. And yes, you can see here there is the grab icon. So this recorded that for the grabbing with the right mapping. So this moving mapping. Here it's a continuous one, meaning it's always playing, it never stops. And then I can just see if that feels all right when I'm moving it around. And that's okay. I would say this creates an interesting feeling. I'm not sure how much time is left. I can maybe go to the next one. Yeah, a little bit. So I'm just gonna show you right there for the slider, the very last mapping that we had with the tool, that is the positional mapping. So here you can see the vibrations. We might want the vibrations to happen in space when I'm reaching this texture here and when I'm reaching this texture here. So if I do that recorded the vibrations based on their position. If I check here, this last mapping is the positional one. I can see there are some vibrations here happen. And when I grab that and I go back on those textures, I can feel the vibration happening right here. This is not exact, so it's a bit around too. This is a bit difficult to have exactly the right position there. But what's interesting is that I can have a different feeling on those two textures, and we can create something like that in other kind of objects. The tool being limited to a 1D space for now, but in the experiment that we did, we had some wall textures, for instance, that were also interesting to investigate in the sense of touching it with the hands and trying different patterns based on their outlook, based on the way they looked, I mean, and the texture they had. And that's about it. I hope you could see everything.
Yes, we did.
Yeah, okay, great.
Yeah, definitely.
So then, okay, I guess we are reaching the end. So I'm not sure if we have time for questions or anything.
Maybe one or two if someone is curious about the demo, for sure. Yeah, of course the schedule is yeah, we are a bit late with respect to the internal schedule, but we are we have, at least we have minutes for questions. If you look at the global IEEE VR schedule. So I guess that if there is someone that would like to ask something.
So yeah, I'm here, and anyway, I can be reached later. So you can also drop your questions somewhere. I'll drop, by the way, the link to the GitHub. If
yes, please. Yes, please.
To check the tool, I'll just do that
yeah.
right now.
Yeah. I have a curiosity because it was not clear to me how the gesture recognition and the synchronization between the recorded gesture and the actual gesture was conducted. Yeah, if there's some controlling in the actual movement that you're doing regarding the vocals that you have. So
Yeah.
it for me it's quite tricky to or at least delicate to understand the action perception coupling mechanism in the second phase, which means the reproduction phase. I don't know if you call it like this, but I hope you got
Yeah, I think I did. So for that, we went with a very naive approach, I would say. That is, when the user is recording something with an object, we check how much distance is traveled with the hands and how much time it takes to travel this distance. And then we put some very simple threshold for that and say, okay, if the distance was short enough and in terms of time also not too long, then that should be an instantaneous one. If the distance traveled is short, but the time is quite long, probably it's a continuous one. The user wants it to keep playing. And then if the distance is above the threshold, something else. So this should definitely be improved with way more fine-grained algorithms and detections. One comment we had from participants in our study was, for instance, when you have a texture and the texture has some very precise details in it, this is where it gets frustrating, because then you would just move your hand on it and the program would just be playing it in a kind of dumb way, this vibration. But actually, when you reach a hole on a texture or you reach a bump, you want it to be exactly there. And this is where it's difficult to have this exact, like at that special position. And this is the trade-off of the approach. That's why we call that prototyping more than designing actually the experience. Because at some point, you probably need to go back to something more parametric. That will be, okay, we know that in this texture, there is something actually exactly here. So we want it to be exactly that way. And this is where the prototyping approach has definitely limitations. On the contrary, in a way, the interesting thing with the prototyping approach is that people do not need to know much about haptics to be able to design those, and they can be just experiencing them and playing with things to ideate some vibrotactile experiences. And once they find an idea they like, then okay, maybe going more into details and actually maybe exporting the experience to go on a more precise tool and then refine it on this tool. But what was interesting is in the experiment we had, we could see still people fine-tuning it, and we had comments and they wanted more fine-tuning capacities, like controlling more, cropping the timing, being able to maybe select some part of the waveform to be able to change it at some point. So it felt like even in VR, people wanted to fine-tune more, which originally we thought people would want more to have playful interactions more than fine-tuning ones. But yeah, I hope that answers the question.
For sure. Yeah. I was thinking if you consider also some machine learning algorithms or something like that to generate some, I don't know, so yeah, some generative networks to compensate for such limitation, which is of course you can cover everything with your voice, or at least you can do a lot with your voice, but it's difficult to model another interaction based on previous one. So I don't know if you have think about a more sophisticated way of generating the stimulus, the vibrotactile stimulus.
So instead of the voice, you mean? So using more an algorithm approach?
Yeah. It's starting from from voice sketching
Mm.
towards a generative approach. Yeah.
So we did not, but that would be super interesting. One thing that was fun is you could use actually any sound in a way. So you could be playing some kind of music next to you and record that while interacting with your objects or doing something like that, which is not exactly an algorithm, but is still taking something that's more precise or maybe a bit more exact than your voice if you really want to reach exactly this feeling that you're hearing. But algorithms could be fun. To me, it's always the question of how much do you control the algorithm? And is it going to be just generating random stuff that might be interesting to some extent, but might also just not be what you want, and then it's hard to fine tune it. And with the voice, you might have more control, but also not so much, because some people have trained voices. If you're a singer, for instance, some they don't have much. But definitely it would be interesting to investigate that more. Yeah, a more generative approach and computer approach in a way.
Thank you so much for your comments. Yeah, we are receiving a lot of messages in Discord. Great demo, amazing demo. So
thanks so much.
Thanks, Bruno, for this demo. Oh, there's a question from Mauricio. Is there any latency when recording recording, I guess, the audio?
Yeah. So yes, and this is where it's a bit tricky, because sometimes you feel that you're actually doing that at a very specific time when doing your action, but there is some latency in all the process of recording the sound and how does it map to the action that you do. And especially for the positional I was showing you, this slider with the textures, this is where it's actually bad, the latency, because specializing exactly on those textures might be difficult. And again, this goes back to also like if you have a planar texture, same idea. If you want to position exactly the audio at one point, the latency is even more a problem in those cases. If you go with a more rough approach, I would say it's okay. But we did not exactly analyze it. I mean, evaluate the latency and how this impacts what the user feels about the experience. But that, I think, would be an interesting investigation for future work. Thanks for the question.
Yeah, also the lightsaber made me so happy.
Yeah, I could see that. That's super nice. It was kind of the killer example to us. Because, yeah, it feels like you know the sound of it, so you know how to actually do the sound of it. And yeah, and it's also to be honest an easy example, because it's a feeling that we don't know. So actually, kind of anything will be okay in this case. Kind of. I mean, it's not like we can rely on, oh yeah, last time I felt that by touching this object. In this case, it's not so much. So we have to imagine it. So it's easier to reach an experience that would feel that would feel real to us, or would feel good enough. And experiment, that's what we could see, that people were enjoying the lightsaber and they were like, yeah, this is a great experience. But yeah, that was fun too.
Yeah, for sure. Familiarity plays a big role in the experience. Definitely. It's like, yeah, characterizing the users, even if you don't know him or her directly. So thank you again, Bruno, for your demo, that it nicely conclude this CIVET 2022. And just I would like to show you that the last slides for a closing remarks. So basically, thank you everybody for participating at the workshop, and apologies again for the misunderstanding for the time schedule. And there's the advertisement. And I would like also to remind you that pretty soon we will have the CIVET book. And this book will cover mostly the basics knowledge and also the basics concepts for the basis of CIVE. And I'm especially for practitioners, young researchers. I think it will be a good source for understanding our research field better. So as you can see, in the topics are it will cover mostly the technological part, the design part, a bit of an eye on the multimodal perspectives, visuals, haptics, and collaborative issues. So this is something that we covered also in this workshop. It was nice to hear about all this of your works with many aspects and in a multidisciplinary field. So thank you again, and hopefully we will see soon in another occasions and venues at IEEE VR 2023. And I would thanks everybody for the participation, and have a nice virtual reality 2022, and that's it, I guess.
Thank you, Michele. It was very nice. Thanks for organizing this.
Thank you so much. And we all have our emails and names and everything, so we will keep in touch for any maybe collaborations or exchange of discussions and next steps for CIVE. Thanks, everybody.
Bye, everybody.
Bye. Have a nice day or night, depending on where you are. Bye. Ciao.